जी स्क्रीन विजिबल है आपको?
Yes, sir.
Okay, so let's start our lecture. So today we shall solve two numerical problems. So let's solve the first problem related to first law of thermodynamics. So here, what is air is contained air is contained in a vertical piston cylinder assembly. So let me draw it. So there is a vertical piston cylinder assembly. So it is a cylinder, piston is attached with an electrical resistor. So inside this cylinder there is an electrical resistor. It means electrical energy is flowing through this resistor. The atmosphere exerts a pressure of 1 bar. Here is the surrounding atmosphere. So in this surrounding, there is a pressure which is exerted on this piston, and that is given as 1 bar. So the atmosphere exerts a pressure of 1 bar on the top of the piston, which has a mass of 45 kilograms. So this piston has a mass of 45 kilograms and a face area of 0.9 meters square. It means the face area of this piston, it will be a circular piston. So this circular cross-sectional area of the piston is 0.09 meters square. Electric current passes through the resistor. This electric current passes through this resistor, and the volume of the air, because inside this cylinder we have air enclosed in this cylinder piston assembly. So electric current passes through the resistor and the volume of the air slowly increases by 0.045 meter cube. So after some time, the volume of this air increases by, this is delta V, which is given 0.045 meter cubes, right? This one. While its pressure remains constant. The pressure of this air during this volume rise remains constant, right? ये जो ambient का pressure है, which is exerted on this air is constant. The mass of the air is 0.27 kilograms. The mass of this air, which is enclosed, is 0.27 kilograms, and its specific internal energy increases by 42 kilojoules per kilogram. So because heat is transferred, and this electrical energy will be converted into heat. This heat is transferred to this air, and then air volume increases by 0.05 meter cubes. And because air is doing work onto the piston, so its internal energy drops. Internal energy increases because of this heat transfer to the air. And at the same time, air is doing work onto this piston. But because of this heat transfer, its internal energy increases 42 kilojoules per kilogram. Right, that is delta small u, because it is kilojoules per kilogram. Total mass is given, that is 0.27 kilograms. The air and piston are at rest initially and finally. So piston starts its movement from some initial state 1 and goes to some initial final state 2. So it was at stop at state 1. It will again stop at state 2. So during this, there is movement of piston. And this change in volume is given 0.045 meter cubes. Friction between the piston and cylinder wall can be ignored the friction between this piston and cylinder walls can be ignored, and the local acceleration of gravity, so acceleration of gravity is g, because air is doing work against this force of gravity, which is 9.81 meter per second square. Now we need to determine the heat transfer q from the resistor to this air in kilojoules, right? In kilojoules for a system consisting of air alone, or part B, when air and piston both are the systems. So in part A, only air. So here you can show a piston. Only air is a piston. So when only air is pistons, then everything outside this system is surroundings. Means piston is also a surrounding. Means this electric resistance heater, which seems to be a part of air, actually it is also a surrounding. Only air is the system. So it means here you can draw the boundary in more detail, that so that you can show this resistance outside the system. So only air is the system. Piston and this resistor, electric resistor, is also a surrounding. So this is part A. So we shall solve part A when air is the system. And then we shall solve the same part with when air and piston both are systems. Okay. So now I have same figure in neat form. So I will remove it. Here is the same system shown. Only air is the system. Only air is the system, right? And into this system, what is coming? This Q. Q is coming because this work, electric work, converts into heat, and this heat is transferred to this air. So this Q is coming from the surroundings, and air is doing work onto the surroundings. This is W. So this is the energy crossing the system boundary in the form of work. This is the heat which is crossing the system boundary in the form of heat. And there is an increase in internal energy, which is given as 42 kilojoules per kilogram, right? And the surrounding pressure against which this air is doing work is 1 bar. That is also given. Mass of the piston is given, area of piston is given. So this is process, not a cycle. So we can apply first law of thermodynamics for a control mass undergoing a process. Right. So for that, we know the equation. The change in volume is given. That is 0.045 meter cubes. Change in internal energy, which is increased 42 kilojoules per kilogram because of this heat transfer. Because of this heat transfer, internal energy will increase. And at the same time, air is doing work. So internal energy will drop. But it means Q is more than W. That's why there is net rise in internal energy. That is 42 kilojoules per kilogram. Okay. And we need to find out this heat which is transferred during this process. So here is the equation of first law of thermodynamics for a change in state and for a control mass, right? So del Q minus del W is equal to delta E of air, because system is only air. So this represents delta E of system. And what is delta E? Delta E consists of three main parts: delta U plus delta KE plus delta PE of our system, which is air. And in this case, the change in internal energy is significant compared to change in kinetic and potential energies in this case. So we may neglect these two changes, kinetic and potential energy changes. So there will be only delta U on the right hand side of this equation. So now the equation is Q minus W is equal to delta U of air. So here the unknown is Q. So this is our equation 1 to find out the heat transfer, which is equal to W plus delta U of air. Okay. So in this equation, delta U of air is given for 1 kilogram, 42 kilojoules per kilogram. So we need to find out the W. So how to find out the W? And we already discussed that W is actually the change in PDV product from initial volume V1 to final volume V2. This is PDV product. Here, pressure against which the air is doing work is constant. It is not changing, right? So the pressure of air, and also there is a pressure due to the weight of the piston. Is air पे जो pressure है, that is not only due to the atmospheric air, but also due to the weight of that piston, right? So this total pressure on this air during this process does not change. That is a constant. So air is doing work against this constant pressure from the surroundings. और ये constant pressure है क्या क्या? There are two pressures. One is atmospheric pressure, which is acting on this area. What is this area? Piston area, which is given 0.09 meter square. Right. So we need to first find out what is this total pressure acting on this air, right? Then we can solve this equation to find out the work done. So let's find out the total pressure is not just atmospheric, but also due to the weight of this piston, which is acting downwards due to the gravity. Weight of the piston is m, and when you multiply m with g, it becomes with a pressure, right? Or a force. M into g will be a force, right, acting over this area. So we can write this equation because pressure is constant, so P is outside, and dV is a change in volume, which is given by V2 minus V1 because it is an exact differential. So in this case, pressure is not changing, pressure is constant. So this equation 2 is simple. Now we need to find out the pressure. So the total pressure, which is acting on this area, right, P into area of piston is equal to, so this is a force, pressure into area becomes force, Newton per meter square multiplied by meter square, newtons is equal to the force due to the mass of the piston acting downwards, M into piston into G, plus the pressure or force due to atmospheric pressure or atmosphere air is exerting a force of P atmospheric, which is the pressure multiplied on which area? The same piston area. This is the piston area, right? So here, this is the total pressure acting on the air from the piston side, which consists of piston weight plus the atmospheric pressure. So now we see what our mass of piston is given, G is known, atmospheric pressure is known, area of piston given, so we can find out this total pressure acting on this air, right? So just put values. Mass of piston, G, atmospheric pressure. Now you have to be careful about the units. That is kilograms. This is meter per second square. So it is newtons, right? This M into G is Newton. So this should be newtons also. So atmospheric pressure is given in bars, 1 bar. So 1 into 10 to the power 5 becomes Newton per meter square. 1 into 10 to the power 5 pascals. Pascal is Newton per meter square multiplied by meter square. So now it becomes Newton also divided by 0.09. So from here we can find out the total pressure acting. So the answer will be in Newton per meter square, and that is 104,905. Or in bars is 1.049 bars. So this is the total pressure which we shall use here in this equation to find out the work done, because delta V is already known. So just by putting values, so here is the work done, which is calculated, right? Now again, units, this is pressure, Newton per meter square, into change in volume, meter cube. Now it is joules. If you divide it by 1000, now it will become kilojoules. So answer will be in kilojoules, which is 4.72 kilojoules. So now we have calculated work. So now using this equation 1, put the value of W so that we can find out Q. So from equation 1, put the value of W and M into delta U. Total delta U is equal to M into small delta U, because what is given? Small delta U, 42 kilojoules per kilogram. Total mass of air, it is not mass of piston because now it is about air, and that is given as 0.27 kilograms. So after putting values, Q comes out to be 16 kilojoules. Right. So this was the answer to find out the heat transfer. That was part A when the system was only air. Now we shall solve part 2 when both air and piston are the systems. Now, the situation is that the only thing is the description of system. System is defined as air and piston both, right? So now how the same equation will be changed. The same equation means the equation which the same first law of thermodynamics for a control mass. This is again a control mass undergoing a process, right? And this side of the boundary is movable, and inside the boundary now we have two things. One is piston, other is air. This is still outside the boundary, this electric resistance wire, but we are getting from this surroundings a heat, because this W electrical energy is converted into heat, right? So now air and piston both, air and piston both are the systems. Same equation for first law of thermodynamics for a control mass, but with what one major change. Del Q minus del W is equal to delta E. Now delta E consists of two parts, air and also piston, right? So the system consists of two things, air and piston. That's why the delta E of system consists of two parts, delta E of piston plus delta E of air. That is the main change. ठीक है, part A में that was only delta E of air. Okay, so now we need to solve this equation. So now again we know delta E consists of three parts, delta U, delta KE and delta PE. So let's write it for both air and piston. Then we shall see which terms are negligible. So here you will replace delta E with delta U, delta KE and delta PE of piston. Here delta E is delta U plus delta KE plus delta PE of piston. In this case, we know kinetic and potential energy changes of air are negligible. So that's why here it will again be delta U. But now let's see what is delta E of piston. Now piston will be moving. So what will change? Its potential energy will change because it is gaining some height, this weight of piston, right? It is moving with some velocity, but that velocity is not given, and also this velocity is not very high, so the change in velocity of the piston is negligible. If it is not negligible, then velocity should have been given here, right? So velocity is not given, so but height we can find out because change in volume is given. So in case of piston, in delta PE of piston cannot be neglected. Third term is delta U of piston. Delta U of piston means if piston is absorbing some of this heat from this air, because heat is transferred to the air is heated up, then some heat may be transferred to this piston. But here what is something special written for piston? Here you see the piston cylinder material is a ceramic composite and thus a good insulator. So it means this piston and the cylinder walls, they are good insulator. It means they will not absorb any heat, right? So it means heat will not be transferred to this piston. Air will be heated up, but because a piston material is of good insulator, some ceramic composite, which is a good insulator, so there will be no heat transfer. It means there will be no delta U of piston, right? So that's why in the case of piston, it will be only delta PE, potential change in potential energy of the piston. And in case of air, it is mainly delta U, change in internal energy of the air. So this equation is written here in detailed form. Delta U of piston, delta KE of piston are neglected. So it is only delta PE of piston. In case of air, it's only delta U. So now our equation reduces to this form. So now Q, which is unknown, is equal to W plus delta PE of piston plus delta U of air. This is the equation which we need to solve for this new system consisting of air and piston. Okay, so let's first find out this W. W will again be given by PDV, right? But now in this case, because this piston is inside the system, that's why work done will be shown here. Work done is this one, crossing the system boundary. Now this system, this whole system is doing work against only atmospheric pressure. In the previous case, this was our piston, this was our system, and this system was doing work against piston plus atmospheric air. But now in the new system, our system is doing work only against atmospheric pressure because piston is inside the system boundary, right? So that is important. So now once we want to calculate the work done, so work done is given by PDV, but now the external pressure against which the system is doing work is only atmospheric pressure. So weight of the piston is not included here for this system, right? So atmospheric pressure is given, change in volume is given, so 1 into 10 to the power 5 Newton per meter square divided by 1000 means answer will be in joules, kilojoules. That comes out to be 4.5 kilojoules. So now W is calculated, which is 4.5 kilojoules. Now we shall calculate change in potential energy of the piston. So what will be change in potential energy of the piston? That is equal to mgh, or mg change in height, where m of piston, which is given 45 kilograms. G is known. Now delta Z, we need to find out how much is the change in height. That is not given. What is given? Volume is given. This change in volume is given. From this change in volume, we can find out change in height, because during this volume change, there is change in height h, or delta Z. And this change in height can be calculated from this, because this change in height is related to this change in volume. This change in volume, delta V, is equal to area of piston multiplied by change in height of piston. Meter, meter square, meter cube. So this is given. Change in volume. Area of piston is also given, so we can find out delta H or delta Z, this one, from this equation, right? So here it is calculated. Delta Z, change in height of the piston, is equal to change in volume divided by area of piston. So that comes out to be 0.5 meter. So values here put kar dein, and then take care about the units. Kilograms, meter per second square into meter. So it becomes newtons, kilogram meter per second square, Newton meter, joules divided by 1000. So answer is kilojoules, 0.22 kilojoules. Now what is left? Delta U of air is already known. So now from our equation 3, W is calculated, delta PE is calculated, and delta U is already calculated too. Actually, it is given, delta U, 42 kilojoules per kilogram into 0.27, right? Because that is capital U, so that will be equal to M into small u. Right, so here values are put करते हैं, W, delta PE, and delta U, which is equal to M into small delta U. So the same answer, Q is equal to 16 kilojoules. So answer will be same as in part A, but the difference is there will be some new terms in part B compared to part A, because when you describe system in a different way, so there are certain changes in the equation which you have to be very, very careful when you are defining your system. Accordingly, you have to solve your problem. Right, Ji. So this was first example. Now let's solve another example. And you will see now we shall solve a next example that is again on the basis of a law of thermodynamics, but the situation is entirely different. Here it was a piston cylinder mechanism, heat was transferred and some work was done. Now let's see another question. In this question, there is a 60-watt fan of a central heating system. Central heating system is to circulate air through the ducts. Now it's not a simple fan which we see in our rooms. That is not a that fan which is installed in our rooms is not used for central heating system. Central heating system is a system which is used in large buildings where you have one big air conditioning system, and that is supplying cold or heated air in the entire building. Right. So this fan is used for that purpose, for a central heating system. Let me show it with the help of a diagram. For example, this here is a duct, because in the central heating systems of large buildings, the purpose of this fan is to circulate this air in the entire building. For example, this air is going into this building, then coming back. So there is a continuous fluid flow or flow of air in this whole loop. In this whole loop, there is a continuous fluid flow. So this operation of this fan is different from the fan which is installed in our rooms. Right. So the purpose of the fan which is installed in our rooms is only to increase the velocity of air. But for this fan, which is making this fluid to flow in large ducts over a long lengths, the purpose is to increase the pressure. Why to increase the pressure? Because when fluid is flowing through these ducts, there is friction. When the fluid comes in contact with the walls of this duct, there will be friction, and the fluid must overcome this friction so that it can flow. And the purpose of such fans in central heating system is to maintain a continuous constant flow. It means to maintain a continuous constant velocity in the whole system. So there is no change in velocity under steady state operation. Once steady state is achieved, so now the velocity throughout will be same. What this fan is doing, it is increasing the pressure. Pressure is the force per unit area, which is due to the resistance between the fluid and this walls of this duct, right? So this force per unit area of this duct, there is a pressure, resisting pressure, which this fan has to overcome. So this fan is actually increasing the pressure from inlet to outlet, not velocity. Or once a steady state is achieved, the velocity in the whole system will be a constant value. जो आपका fan है which you see in our rooms, उस fan का purpose, मैं अगर वो fan show करूँ यहाँ पे, this fan which is not flowing the air in some duct, it is only taking this air at very low velocity and throwing it at a higher velocity. But this air is not moving through some duct. But here, this fan is making the fluid to flow in a duct. Okay, so now with this background, let me read what is written here. A 60-watt fan. So 60 watt means this energy which is supplied to this fan in the form of work or electrical work. So a 60-watt fan of a central heating system is to circulate air through the ducts like this one. The analysis of the flow show that the fan needs to raise the pressure of air by 50 pascals. So this fan needs to increase the pressure by 50 pascals. So let me define a system, for example, because the fan is located in a horizontal flow section that is given. ये कोई horizontal flow section है where fan is located, mass is entering, mass is leaving, and from inlet to outlet, this change in pressure, delta P, is 50 pascals. This is inlet, this is outlet. So P2 minus P1 is 50 pascals. V2 minus V1 is 0 because constant velocity. Potential energy at point 2 minus potential energy at 1 is also negligible. What is crossing the system boundary? Work, electrical work, that is given as 60 watts. So that is the description of this problem. What else is given? The fan is located in a horizontal flow section whose diameter, this diameter is given 30 centimeter at both inlet and outlet. Determine the highest possible average flow velocity. So under these conditions, what will be the highest average flow velocity? Highest average flow velocity which will be developed. This V in meters per second is to be determined, right? When there is a pressure change of this much, work is entering at this rate, right, 60 watts, then what is the maximum possible velocity which will be achieved in this system? That is the problem. So this, now you can see the nature of this problem is entirely different from the previous problem, right? यहाँ पे कोई heat transfer नहीं है और ये कोई piston cylinder mechanism नहीं है. That is not a closed system, that is an open system. Mass is continuously entering, mass is continuously leaving the system, right? So that's why. Okay, जी, let me. Okay, जी, I need to put you on hold for a few minutes, okay? Okay, जी. So can you hear me?
Yes, sir.
Or
Yes, sir.
screen पे visible है?
Yes, sir.
Yes, sir.
Okay. So let's start again from where we left. Okay. So here you see the schematic जो मैंने explain की थी detail में. Here is the short schematic. So exam में भी आपने हर question के बाद उसकी एक schematic diagram. Here you can see you have defined a system with boundaries. इस system के cross there is electrical energy crossing, there is mass crossing, mass leaving. ठीक है, this mass is entering, this mass is leaving. Mass has energy in it. Which energy? Only pressure energy is relevant because there is a change in pressure from inlet to outlet. Change in velocity and potential energy for this fan is negligible, right? Because this is a fan which is making the fluid to flow in a circular duct, not, right? Not like a roof fan or ceiling fan. Okay, so now this is the system. So let's write its equation. Now it's first law of thermodynamics for a control volume, right? So first law of thermodynamics for a control volume by neglecting kinetic and potential energy changes. So that is zero. So what is first law of thermodynamics for a control volume? It is E dot in. Now there is a dot because there is watts are given, joules per second given, joules nahi given. So E dot in minus E dot out is equal to delta E of system, but here it is a dot, so that should be divided by time dt. Now this system is under steady state. Continuously there is a certain mass entering, certain mass leaving, and the work which is transferred, that is also constant, 60 watts. So under a steady state condition or steady flow condition, this change in energy within the system is zero. For a steady state system, the changes within the system with respect to time will be negligible for a steady flow system. If it is not a steady flow system, it means with the passage of time, there is some energy accumulation within the system. So with respect to time, there are changes within the system. So which is not here, which is not the case here, because this is a steady flow system. The last problem हमने किया था, that was not a flow system because mass was not flowing, mass was fixed. And this fixed mass, its energy was changing when there was a process. But here, it's a steady flow process because fluid is flowing. So with respect to time, the changes within the system are uh, constant. So that's why it is zero. So now the equation is simple. E dot in is equal to E dot out. So all of the energies which are entering this system in the form of mass and heat or work, so only work. So this is the energy entering, m dot into P1 V1 or P1 over rho 1, right? This is specific volume. PV is energy per unit mass multiplied by m. This is pressure energy at inlet is equal to pressure energy leaving, m dot into P. It's small v. It seems like capital V, actually it is small v, P V or P over rho. So that is the equation of first law of thermodynamics for this system, right? Now इसमें देख लें जो unknown है उनको हम एक साइड पे कर लेते हैं. W dot in which is given is equal to m dot into P2 minus P1, P2 minus P1, because this delta P is given to us. Change in pressure, P2 minus P1, that is 50 pascals, which is given. Now we need to find out the velocity. So in this whole equation, there is no term of velocity. So let's see how we can introduce velocity here. This m dot into small v. Small v is specific volume. So what is this term? This m dot is kilograms per second. Sorry, kilograms per second. And this v is meter cubes, because it's specific volume, meter cubes per kilogram. So now it becomes kilogram will cancel with kilogram. Now it is meter cube per second. It means this m dot into v represents volume flow rate, meter cubes per second, right? So from this equation, we can say that this m dot into v represents capital V dot volume flow rate, right? W dot in known, delta P is known. So on unknown is this m dot V, which is actually volume flow rate, meter cube per second. So we can find out this. So we can write it as capital V dot delta P, where this capital V dot is volume flow rate. So from here we can find out volume flow rate, right? Maximum volume flow rate through this duct, because we are neglecting frictional effects. That's why the volume flow rate will be maximum under these conditions. Okay. So now put the values of work, 60 watts divided by pressure change, which is Pascal. Right, 60 joules per second divided by 50 pascals. Pascal is also joules per meter cube. ये भी हम थ्योरी में पढ़ चुके हैं, because pascals is actually newtons per meter square, right? So if you multiply or divide with meter, then Newton meter divided by meter cubes. So that Pascal actually represents joules per meter cube, energy per unit volume. So joules per meter cube, here you have joules per second. The answer will be in meter cubes per second. Joule with cancel with this joules. So answer is 1.2 meter cubes per second. So that is the volume flow rate. But we need to find out the velocity, not volume flow rate. So we also know that volume flow rate V dot से हमने mention किया, capital V dot is equal to area of flow, the passage through which fluid is flowing, multiplied by velocity, meter square into meter per second. So from here we can find out this velocity, because we need to find out the highest possible average flow velocity. Highest possible simply means by neglecting the effect of friction, because actually there will be frictional losses from here till here. Motor may be losses honge here, so all those losses are neglected, right? So then whatever velocity or flow which we will get from this device will be maximum, right? So area of flow is it's a circular duct whose diameter is given, so we can find out its cross-sectional area through which fluid is flowing, right? So the maximum velocity is given by volume flow rate divided by area. So just values put current, this is maximum flow rate divided by pi by 4 d square, so that is 12 meter cubes divided by pi by 4. So that is the velocity. So this is the velocity which will be obtained here, 17 meters per second. That was the unknown. Determine the highest possible average flow velocity in this duct under these conditions. So now you can see that every problem can be solved with the same first law of thermodynamics. E dot in minus E dot out is equal to delta E of system. But first of all, you need to define the system properly. And properly means the important energies should be crossing the system boundary. Like in this case, mass was entering, mass was leaving. That was a flow process. Previous question, it was a closed mass inside a piston cylinder mechanism. And here no heat transfer is given, so that's why only W. So that must be crossing the system boundary. So in every problem, always draw the schematic diagram first. Clearly show what is inlet, what is outlet, then show all the data on it. The surroundings should be very clear. All the energies should be crossing the system boundary. अगर आप यहाँ पे boundary इस तरह draw कर दें, so it is wrong, because across this boundary nothing is crossing. No mass is crossing, no energy is crossing. So that representation of boundary is wrong, right? So in the exam, always try to show the proper boundary and the energies which are crossing, then write its equation. So whenever you write the equation, again you have to be careful about the units. It is E dot or only E or small e, right? So in this question, because watts, 60 watts was given, because it is a flow, it means m dot, everything is changing, is with respect to time, not changing, constant, but with respect to time there is 60 joules which are entering. There is certain mass which is flowing with respect to time. So that's why everything was dot. In the previous question, it was without dot, right? So these things which you have to be careful. अब आप जितने भी क्वेश्चन सॉल्व करेंगे न्यूमेरिकल्स और एग्जांपल्स, आप सब में देखेंगे हर न्यूमेरिकल, हर क्वेश्चन की जो स्टेटमेंट है, दैट इज जो सिचुएशन है, दैट इज इंटायरली डिफरेंट. So solve each and every question by yourself. Otherwise, कोई भी unknown situation आएगी तो एग्जाम में इतना टाइम नहीं होगा कि आप उसके ऊपर देर तक सोचते रहें और फिर उसे अटेम्प्ट करें. So try to solve each and every question by yourself. Okay, जी. So any question, then ask.
सर ये एरिया कैसा है रीमिक्स का, ये समझ आ नहीं था.
एरिया यहाँ देखे ना, इस प्रॉब्लम में here the fan is located in a horizontal flow section whose diameter is 30 centimeter. That is given. ये जो diameter है flow section का diameter है, तो it means कि ये कोई circular duct है. When diameter is given, so we can find out its area, pi by 4 d square, cross sectional area across which this fluid is flowing. ये fluid flow कर रहा है इस cross sectional area के across. So that's why this area is calculated from this given diameter, right? सर्कुलर डक्ट होती, कोई और डक्ट होती तो फिर उसकी साइड्स कोई रेक्टेंगुलर या स्क्वायर डक्ट होती तो फिर उसका एरिया होता. जी, एनी अदर क्वेश्चन?
Yes, sir.
ओके जी, सो इफ देयर इज नो क्वेश्चन, सो ये चैप्टर 2 अब ऑलमोस्ट हर लिहाज से कंप्लीट हो गया है. सो नेक्स्ट वीक हम चैप्टर 3 को ही डिटेल में पढ़ेंगे. ओके जी, सो थैंक यू सो मच. Class is almost